Alright, this is a very nice question. We are given this integral and the goal is to find the positive difference between the trapezoidal rule when we use n is equal to 4, so 4 trapezoids, and the exact value of that integral. So we are doing two things. In fact, let's compute the exact value of this integral first. Because this right here is actually just a what? A semicircle, right? So if you graph it, square root of 4 minus x squared, it goes from negative 2 to 2. It's a semicircle. So we can interpret this integral as the area under the curve. And the area is just going to be half times pi times the radius squared. And the radius is just equal to 2. So work that out. That's 4 divided by 2, so it's just 2 pi. So this right here is the exact value of that integral. Okay, then how do we do the trapezoidal rule? And this is how I like to show you. You don't really have to draw the trapezoids. You could. It's like right here, right here, right here. And then you really just draw the trapezoid like this, right? The first one is kind of like a triangle because when x is at negative 2, the height is 0, so it's like a triangle, but you can interpret that as a trapezoid. And the next one is like this, okay? And then so on. So if you look at the picture, you can see that the trapezoidal approximation is going to be less. It's underestimating the exact value of this integral. Now this is how you can do the trapezoidal rule. First, notice we go from negative 2 to 2 and we have 4 intervals. So you can compute the delta x real quick. It's always going to be b minus a over n. When we have an integral, it goes from a to b. So you can just do 2 minus negative 2 over 4 because we have t4, so n is equal to 4. So delta x is just equal to 1. So that means you go from negative 2 and you add 1. So you get to negative 1. And then you add 1 again, you get 0. And then you add 1 again, you get to 1. These right here are the x values that we will be using. Now for t4. Firstly, you have to remember that you take delta x and you will have to divide it by 2. Because the area of a trapezoid is 1/2 times the sum of the two bases and then multiply by the height. In this case, the height is the delta x, if you look at the trapezoidal sideway. Okay, and then you have the following. F at the first x value. Our function is this, square root of 4 minus x squared. And the first x value is negative 2. And next, when you plug in the next x value into the function, make sure you multiply the result by 2. And the reason is because f of negative 1 gives you the base, right? This height right here for the trapezoid. And it actually, you have to use it twice. The first one with this one right here, and then the second time with the second one right here. And that's the same for the next one. You do 2 times f of 0, and then you do 2 times f of the next one. But for the last one, this side is only just 1 time. So just f of 2. Okay, so we have 1, delta x is 1 over 2 times f of negative 2, plugging negative 2 into here. That's just going to be 4. 4 minus 4 is 0, so it's just 0. Plus 2 times f of negative 1, plugging negative 1 here. It's just 4 minus 1, which is 3 in the square root. F of 0, plugging 0, you get square root of 4, so it's just 2 times 2. And then 2 times plugging 1, you get square root of 3. Plugging 2, you get 0. Okay. Here, you can reduce out the 2, and I will just do it like this. It's slightly better this way. I will say this is just, together you have 2 of this. So it's 4 square root of 3 plus 2 times 2. And then you can reduce out the 2. So it's 2 square root of 3 plus 2. Alright, so this is the T4 value. Now, finally, we just have to do the exact value, subtract T4, and we'll be done. So finally, the positive difference between the integral and the trapezoidal rule, the result of the integral is 2 pi, and then we are going to minus, the answer was 2 square root of 3 plus 2. So we have 2 pi minus 2 square root of 3 minus 2, and then we can factor out 2. So pi minus square root of 3 minus 1, and this right here is the final answer.